Grow revenue with dehumidifiers and crawlspace encapsulation. After taking today's course, you will be able to explain how thermal dynamics affects homes, demonstrate knowledge of the IRC encapsulation energy code, explain differences in techniques used to control moisture in crawlspaces, perform a crawlspace inspection for moisture issues, use inspection tools to detect moisture levels in crawlspaces, detail the crawlspace encapsulation process, explain why dehumidifiers are the only viable way to remove humidity from a crawlspace, understanding thermal dynamics. One basic component that I want to make sure that everybody understands, and this is the second law of thermal dynamics, and this is really what we need to think about when we are looking at dehumidification in homes, is hot goes to cold, wet goes to dry, and high goes to low. So anytime that we go in and we try to look at the customer's home when it comes to dehumidification, the answer, we really need to look at what's going on to make sure that when we apply that dehumidifier, it's going to be successful. As we go in deeper on the different ways that code approved ways to condition a crawlspace to manage moisture, we always need to keep in mind this thermal dynamics law. Hot goes to cold, wet goes to dry, and high goes to low. When we look at crawlspaces, it's important to note the fact that there's a lot of opportunity in this area. When I say opportunity, I'm referring to the fact that these areas are synonymous with moisture, termite, and other insect issues. Crawlspace foundations are widely used in building construction throughout the United States. This is proven by the fact that around 250,000 new homes are built on crawlspaces each year. There's also an estimated $76 million such structures already in existence. Due to energy efficiency building codes, green building standard programs, and incentives, more crawl spaces are being encapsulated. These programs are driving for HVAC mechanicals to be in conditioned spaces. According to various surveys, adding a high-performance energy-saving feature like crawl space encapsulation can offer an average 10% return on investment when a house sells. I believe this is important to note because encapsulating a crawl space is a large labor-intensive job and does come with a price tag. So why do we encapsulate crawl spaces? One big reason is for energy consumption. When it's hot outside and that air is coming in below the home, you're going to be heating up that space. In the colder times of the year, when you have a crawl space that's ventilated to the outside, the insulation underneath, the subfloor area isn't enough. The reality is, we're still bringing a lot of cold air into the house. This is another reason why energy consumption is a big reason why people encapsulate crawl spaces. According to Advanced Energy, homes with vented crawl spaces are 19 times more likely to experience high relative humidity levels in excess of 70%. This can lead to a lot of rot, cupping, and buckling of hardwood flooring, and even damage to cabinetry. Again, if it's hot and humid outside and we're bringing in that air below, we're causing a lot of damage below the home that is ultimately going to go into the house. These high humidity conditions allow termites and other insects to thrive, while also providing conditions conducive to microbial growth. Other issues with these high humidity conditions include the potential for structural issues and poor air quality in the living spaces. As you're seeing, there's a lot of reasons to not have vented crawl spaces. As we've become more advanced in the construction and pest control industries, we've figured out that encapsulated crawl spaces are a great solution. Overview of the encapsulation process. The encapsulation process involves 4 things that we have to address. First, we have to address bulk water. We can't encapsulate a crawl space and still have water intrusion issues that aren't resolved. Adding a sump pump is the best way to resolve the issue inside of the crawl space, along with things like making sure gutter downspouts are directed away from the foundation on the exterior. You may find that it's prudent to add French drains to the bottom of these downspouts in some cases. In cases of extreme water intrusion, exterior grading may be required to divert the water away from the foundation. For today's exercise, we're going to assume these issues have been corrected or aren't an issue. In my experience, the majority of crawl spaces don't have major issues with water intrusion. With air infiltration and water vapor, these steps will mainly be addressed with our moisture management step. Looking at moisture management, we need to understand that one of the biggest goals is to manage relative humidity, or RH. Here's an example of an exceptional encapsulated crawl space. Obviously, they don't all look this good, even after encapsulation. We just wanted to show you what a stellar one looked like. This is more of what you would typically see on an encapsulated crawl space. There's nothing wrong with the workmanship on this. In reality, taking into account the fact that the crawl space floor is never perfectly level and the fact that you can only stretch the vapor barrier so much, this is a solid encapsulation. With this crawl space encapsulation, we have a good vapor barrier on the floor and the walls. The issues related to air infiltration have been addressed not just from the outside into the crawl space, but also from the crawl space into the living space. Moisture management. Even in closed crawl spaces, without proper engineering with some moisture management system, they will still experience high humidity levels. This is especially true in the times of the year when the humidity is high outside. This is the time of the year when damage to the home is most likely. Anyone in the home with respiratory issues may have their breathing affected due to microbial growth in the crawl space area. In the pest control industry, we all understand that pests like high humidity, and this always leads to more conducive conditions for pests. At 85% humidity, we get wood rot and blistering of paint. At 75% and above, we get cupping of wood floors and stains on walls and ceilings. When you're consistently above 60%, each conditions are ripe for mold, mildew, and microbial growth. When it comes to mold amplification, it's important to note that mold needs 3 things to grow: organic food source, elevated moisture, and temperatures in the 59 to 86 degree range. Crawl spaces provide ideal conditions for mold amplification, even closed, encapsulated ones. I'm saying this because when a crawl space is enclosed, it can still have that elevated moisture. It can still have those temperatures and can still have an organic food source. The point being made here is these closed crawl spaces are still going to be a problem if they're not using something to remove moisture. We put this in the course because we wanted to remind you that you should never use the word mold unless you are a certified mold remediator. Microbial growth is a much better term to use in place of the word mold, since there is a form of microbial growth in this crawl space, and it does need a defining term. This is something you would commonly see when inspecting crawl spaces in the humid parts of the country. The #1 photo for crawl space mold is efflorescence, which is minerals coming through the block foundation. This is not mold. If there is mold, we would encourage you to have that homeowner hire someone that is certified to perform mold remediation if you're not qualified. To stop mold or microbial growth, you have to control moisture and the moisture content in wood. The wood moisture content should be less than 16%, and the relative humidity throughout the space should be maintained below 60%. With uncontrolled relative humidity, wood will swell. This is particularly a problem with the floor joists and subfloors in crawl space areas. Encapsulation Energy Code 2021, IRC. We are now going to talk about building code and all the ways that are acceptable ways to condition a crawl space. One reason why we're bringing up the 2021 code is because it's the latest code. The previous code was put out in 2018, and you need to remember that the 2021 code trumps the 2018 code. When it comes to the 2021 code on unvented crawl spaces, in section 2.1, continuously operated mechanical exhaust ventilation needs to be at a rate equal to 1 cubic foot per minute for each 50 square feet floor area, including an air pathway to the common area, such as a dot or transfer grill, and perimeter walls insulated in accordance with section N11122-11 of this code. I'm showing you all of this information because when you go into a crawl space that has been closed, by code it has to have the correct exhaust, ventilation, air pathway, and wall insulation. The other purpose of this is you being able to detail on an inspection why a closed crawl space isn't meeting code and provide the client with a solution to help solve the issue.
In Section 2.2 of the code, the conditioned air supply has to deliver at a rate equal to 1 cubic foot per minute for each 50 square feet of underfloor area. including a return air pathway to the common area, such as duct or transfer grill. Perimeter walls are to be insulated in accordance with Section N 1102.2.11. In Section 2.3, the plenum in existing structures must comply with Section M 1061.5 if underfloor space is used as a plenum. I've never seen underfloor spaces used as a plenum, but we did want to mention it since it's part of the code. In Section 2.4, the code requires dehumidification sized in accordance with manufacturer's specifications. With continuously operated exhaust ventilation, one of the pros is that the equipment is relatively inexpensive. You're going to see that as we go through this. The equipment is going to be relatively inexpensive, and that's why builders typically like to go this route. Then, we commonly see other contractors come in and try to sell a conditioned crawl space cheap and cut all the corners to do it at a low price. This leads to situations where the moisture never really gets controlled. Once the crawl space has been conditioned correctly, the air infiltration issues and bulk water issues have been solved. All we need to worry about is relative humidity. What I am alluding to here is the fact that conditioning really means moisture control. The cons with this mechanical exhaust ventilation is it will most likely increase the humidity in the living space of the home in the humid times of the year. I'm going to show you why in just a minute. This system is not good for indoor air quality and can cause comfort issues throughout the house. The reason being is the effect it has on the crawl space. Basically, we have our floor grill that is allowing conditioned air per code to come into the house, and we are exhausting it out of the vent in the crawl space. The challenge with this is when you exhaust air out, makeup air has to be brought into that house somewhere. The house is always trying to equalize. So, when we talk about thermodynamics, the second law, where high goes to low, if we're exhausting here, then going to be pulling air into the attic area. This potentially brings in hot, humid air from the outside into the upper levels of the living space, and then pulling the air through the rest of the living space to exhaust. We typically don't want to create that type of negative pressure. This is especially true in hot, humid climates where we commonly see crawl spaces. When you come across these types of homes and check the RH levels in the spring, summer, or fall, you will likely find high RH levels. Looking at conditioned air in the crawl space, I can tell you that I see this one quite a bit. No equipment is really needed besides some supply register and floor register. The theory is that when you're air conditioning during the humid season that you're putting dry air into that space. The challenge with this is the air is usually cold air. When you decrease the temperature of air, you increase the RH. For every degree you go down, the RH goes up 2%. At that point, we're putting cold air into a cool space. You can already have high humidity down there, and all you're trying to do is put cooler, drier air into the area. This is not a good conditioning method for a crawl space area. The only reason this is done is because it's inexpensive. Unfortunately, I see it quite a bit throughout the Mid-Atlantic and the Southeast. Here's an example of what this looks like. They basically tapped into the supply plenum and added a register. Here is a rendering of how that looks. Basically, you've got your passive returning grill here. You're moving some supply air from that. Again, here's another illustration of the conditioned air, and then we've got our floor grill there to share the air between the spaces. This is actually the data we collected in Northern Virginia on 2 habitat houses built on the same lot. Basically, the same exact houses. We will go over this quickly because there's a lot of data here. These dotted lines are what is going on in the crawl space, and the solid lines are what's going on outside. So, we had 2 exact homes. We encapsulated them both. One of them we put in a dehumidifier, and the other one we used to supply air from the AC. This is a small glimpse of what we found. I had to shut off the alarm on the one using the air supply because it was consistently above 70% in the spring, summer, and fall. You can see when we add a dehumidifier, we set this one pretty low. It was new construction and before they actually finished the home and closed it up for the homeowners to move in. They did have to remediate that crawl space just from having electrical wires and things like that through it. We set it low from the get-go to help it dry out. You can see we have a good dew point going on here. We were around the 50% range. 55 is ideal and we were in a good range here. We have low RH. We did go back in and increased it to 55 pecent. Once we saw it had dried out well, the temperature stayed pretty consistent at about 74 degrees in the crawl space. You can see the RH shot up when we had some rainy times here. What this shows is, we were able to keep the RH controlled in the crawl space no matter what was going on outside. Keep in mind this was in Northern Virginia in April and the AC was not being used a lot. As we look at the other house with the AC supply being used to condition the crawl space, we have the same thing with the RH outside during the rainy time. You'll also notice the dew point getting above 60 degrees and making the crawl space area conducive for condensation. The RH was consistently getting to that 70% range. Again, if you're counting on supply air to condition the crawl space, the AC has to be running to even push that drier air into the crawl space. This is just not a consistent way to control RH. Underfloor space used as a plenum IRC are 408.3 M1601.5 underfloor plenums. Underfloor plenums shall be prohibited in new structures. Modification or repairs to underfloor plenums in existing structures shall conform to the requirements of this section. What that means is you're turning this cavity in the floor joist into a path for supply and return air for the HVAC system to control and condition that space. If you see this in a crawl space, this is probably your number one opportunity to add a dehumidifier. This air is then traveling throughout their house because it is being pulled into the AC system. Let's talk about a fan between the crawl space and the living space. This is another strategy someone might use that may or may not meet code. This is just sharing the air between the living space and the crawl space to condition it. This is once again being used to try and control the relative humidity. Here's another illustration of what that might look like. If you see a powered fan like this, it's not for radon, even though it looks like it. It's just to bring in air from the living space. Powered exhaust fan between the crawl space and the outside. What we're trying to do is control the air below the house using a powered exhaust fan. These typically run off of some sort of sensor that identifies when the RH in the crawl space has gotten too high. It will then exhaust air out and bring in new air through another vent. It's important to note this only works if it's drier outside than it is inside, as we have been talking about. In the spring, summer, and fall in a lot of regions, the dew point will be too high for this to be effective. Also, if it's cold outside during the time of year, then you're most likely bringing in colder air. This colder air can create colder floors and higher energy usage that no one wants. The image on the screen gives you an idea of what that looks like. All these things have two things in common: little to no equipment costs, do not manage humidity year-round, allows for airflow communication with the living space. These techniques may save a few dollars, but the goal of managing humidity isn't met and the whole purpose has been defeated. Because this allows communication between the crawl space and living space, those of you in the pest industry dealing with termites. At times there will be chemicals that have to be used in the crawl space. Typically, you would not want those chemicals being pulled in or shared with the living space. Things to look for in a crawl space include musty odors. When you walk into a living space with musty odors, that's most likely because 50% of the air in the home is coming from the crawl space. This is more often during the heating times. In reality, though, the air is going to be shared year-round with any of the methods we have been discussing. Whenever you smell these musty odors, you will need to take measurements of how high the RH is in the crawl space. This is something very important to be able to share with the homeowners. When you see the homeowners have the thermostat on a low setting, it could be more of a comfort issue. It doesn't matter if it's because of high RH or temperature. The first thing they are going to do is go to their comfort control center and start cranking down that thermostat. It very well may be because they have high RH in the crawl space. Potentially, if there's condensation on the ductwork, that means there's high RH in that crawl space. Microbial growth can be an issue at that point. We don't know what it is, but there's an environment that is allowing some growth. You may see a portable dehumidifier where they went out to somewhere, like Home Depot, and picked one up. You may even see these portable dehumidifiers in the living space. Another thing to look for is portable air cleaners. If you see these in the living space, this tips you off there may be an issue in the crawl space. Finally, any cupping or other hardwood floor issues would be another telltale sign of issues in the crawl space.
Let's talk about crawl space inspections. Remember, performing a crawl space inspection is a complex undertaking. One of the first obstacles you may face is the clearance from the floor joist to the soil grade. As you can imagine, instances where you have less than 18 inches can make crawling these areas virtually impossible. Keep in mind the fact that it's worth all the effort to crawl the tight spaces because you will find issues that need to be resolved. And I tell people this all the time, it's very important to get in these crawl spaces because if you don't, you're not really taking care of your customer. The fact of the matter is that they can be very tight. I've even had instances where we had to dig our way through a crawl space, move soil and different things. But that's where you're going to find the major problems, especially as we're going to talk later about like moisture issues. The closer the floor joists are to the soil, the more problems there can be. So I do understand if it's less than 18 inches, especially, it can be really tough to crawl. But you really want to get underneath there. It's going to be good for your business, good for the customer, and everybody's going to win.
So what type of tools would you need when doing an inspection? You know, if you ask different people, you're going to get a wide variety of answers to this question. I would definitely tell you this, just looking on our screen, one of the things that I like are tweezers and probe tools. Definitely like brushes. Flashlights are imperative. You really can't do an inspection at all without a flashlight. Black lights can be good to show things like urine, things like that. A good inspection mirror as well, because with a good inspection mirror that's flexible, you can look up underneath things and behind things a whole lot easier. Now obviously you could use things like an aspirator, a white rubber mallet. Specimen vials can be good just to collect any insects you may find. Knee pads are a good idea because they protect you when you're crawling in crawl spaces and areas like that. Screwdrivers and a magnifying glass. And of course a Termatrack eye tracker we really like because there's a lot of functions that can help you do a great inspection. Inspection techniques and equipment. As we mentioned before, good light is essential. The inspector should carry an extra flashlight to prevent unnecessary delays during inspections. A heavy jackknife, awl, or dental tools for probing into the wood is also a necessity. A thick piece of spring-sealed or a hacksaw blade is needed for testing earth-filled porches. A screwdriver, measuring tape or wheel, and a small hammer should be included with your equipment. A light, strong ladder is essential. Coveralls, a stocking cap, gloves and knee pads, chalk, respirator, telescoping mirror, hand microscope, magnifying glass, and an eye tracker make up the balance of the essential equipment. Some inspectors carry cameras or use their phone to photograph special conditions. A legal-sized clipboard equipped with inspection tags, ruler, and pencil is handy to sketch a diagram of the structure and make notes of findings.
So the way to get started on the inspection is to enter the crawl space and inspect in a clockwise format. You can see the little diagram we've drawn here where you actually see the crawl entry door. You're going to go in and you can see yellow marks on this diagram to where we're actually showing where you shine the flashlight to all the walls and you take a look at everything. Always do it in a clockwise format to make sure you shine all walls. Now I do understand there can almost be like separate rooms and things inside of a crawl space. It's almost kind of interesting how you can go through a little opening and end up in another room. But keep in mind, if you work in a clockwise format, even if you're in a main crawl space that opens up to a smaller one, you just go into the smaller one, do the clockwise format, come out, and then pick up right where you left off in the main crawl space. But this is a way to make sure you don't miss anything. Inside a crawl space, there's just so many different things that can be going on. You really need to get a full idea of what you can see while you're under there. So go in, do the clockwise format inspection, but keep in mind you're also going to need to write things down when you get out. So you really either got to have like a notebook in your pocket, maybe a little notepad, or have a good memory of the things you see, because once you come out of that crawl space, there's going to be a lot to figure out in your mind when you're drawing a diagram and things like that. and you really want to make sure you note everything. And again, take photos as you go, because this will help you doing the inspection and help you draw the diagram at the end. One of the biggest things you're going to run into in a crawl space is termite activity. Once again, you're going to need to make sure you're shining all walls to look for things like this. You also need to look at the block piers in a crawl space to make sure there's not any activity around those. So as you can see in the photo here, there's some nice big termite tubes that have built up the outside wall of a crawl space here. Piers is the same way. I mean, the block piers that the crawl space sits on, you're going to find activity around those too, especially when it comes to termites. So you need to make sure you shine all these areas. Once again, you're going to need to be looking for things like the tubes. You're going to need to be looking for moisture. Obviously, as you go, you're going to see more and more things. Like in this particular crawl space, the vapor barrier was really broken down. So there's just a laundry list of issues you can come across, but make sure, again, you're shining all the walls, the piers, and make sure you're keeping a mental note or a notepad to write down your inspection findings when you're done. The photo on this screen is a picture of termite tubes found in a crawl space in Florida. One of the things I want you to be aware of is the fact that drywood termites can also infest crawl spaces. This is going to be most common in the Gulf coastal states to the Carolinas, even places like New Mexico, Arizona, and California. So if you're in the Midwest, the Northeast, the Upper Plains, you're definitely not going to have a problem with this. But it is something to note that there can be drywood termites, and you're going to be looking for things like frass and their fecal pellets in the crawl spaces.
The eye tracker made by Termatrack can aid us in identifying if the termites are active or if it's old evidence.
Another interesting thing you're going to come across in crawl spaces is fungi and microbial growth. There's a lot that could be said about these things, and each state has a different idea of how they look at this as far as treatments, as far as what you need to write down on inspections. But I did want to let you know that fungi are common in crawl space inspections. This is especially true in more humid areas in the eastern U.S. and along the Gulf Coast and even in the Pacific Northwest. So if you're in a drier area, say like West Texas or Arizona, California, Nevada, you may not see as much of this because the relative humidity is so much lower. In this photo here, these are fungal spores of a crawl space we observed in the state of Tennessee. But I just wanted everybody to know, really look at the floor joists, look at areas that might have fungi like this. You can even take your finger and smear across them and see if those fungal spores smear, then you're definitely going to know they're active, whereas they could be dead if they don't smear. But again, if you're seeing them, it's better to err on the side that they are active and is something you need to look at performing treatment for. On this slide, you're just seeing a couple more examples of fungi. You can just see they're just little plant-like growth that grow on the wood. So whenever you see this, it almost looks like specks, but they're a little bit taller. You're definitely going to know this is fungi you're seeing. Another thing you need to think about when you're doing your inspection is if the fungi is active or not. As you can see in the photo here, you would actually take your finger with your gloves on, rub across the fungi and see if it smears. If it smears, it's definitely active. This is going to help you out when you think about how to remediate problems in the crawl space. If you're dealing with an active fungus, it's definitely different than if you're dealing with one that's dried up. So keep in mind you always want to do the smear test to see if the fungi is active or not. I wanted to talk to you a little more about surface molds and sap-stained fungi. Surface molds discolor the surface of the wood. Surface molds do not weaken the wood, which is very important to know. Surface molds are usually green, black, and orange or powdery in appearance. Concerns with these are respiratory and not structural, and that's a big deal because a lot of people are concerned about microbial growth and how does it affect the structural members of the home. These spore or seeds of surface molds grow quickly on moist wood. Large quantities indicate excessive moisture. Control involves reducing or eliminating the source of moisture. So I want everybody to know again, surface molds can come in multiple colors. I don't really have a photo necessarily of the orange ones. If you've ever seen the orange powder surface molds, they're very interesting. They are a bright orange color. It's kind of impressive what they look like. But I want everybody to know that these are more of a respiratory issue. At the same point in time, most people, if you showed them photos of these, wouldn't be happy that's going on in the crawl space of their home. So you need to just keep in mind as you're thinking about treatment plans, how you can solve these. A lot of the control it basically involves reducing or eliminating the source of moisture, but there's also other things you can do. And if you're seeing large quantities of these, there's definitely a major moisture issue. So you need to be thinking to yourself, what can I do to reduce that moisture? And as we go through the next few slides, we'll talk about some things that you can do to help that problem. In this slide, you're going to see some surface fungi. As you can see on this surface fungi, it's actually a yellowish orange color mixed in with some greens, but it's a real powdery looking fungi. This is something I wanted everybody to see because this is something you will run across in crawl spaces. Typically ones that have a pretty good moisture content, but it's kind of impressive to see. It can even be like a really, really bright orange, kind of like an orange, the fruit itself, but here it was a little bit discolored, but the point is that you will come across things like this in crawl spaces. We're going to look at wood decay fungi. This is a little bit different because a wood decaying fungus cannot make or capture its own food. It actually feeds off materials such as wood. And I want to stop there because you can figure out in your mind that if it's feeding off the wood, then we've got some major issues that can happen. Obviously, with a name like wood decay fungi, you already know that it's definitely doing some damage to the wood and the structure itself. The wood decay fungi secrete enzymes that break down wood components into sugars. The body of the fungus is made up of long thread-like strands. Strands combine into mats and produce reproductive structures. Severe wood decay can occur in wood with greater than 20% moisture. These are going to break down and compromise the integrity of the wood. So once again, people are definitely concerned about like the respiratory issues we talked about in the last slide, but they're going to be even more concerned when you're breaking down the structural integrity of their wood. So you really need to do a good inspection when it's coming to something like this because structural issues are going to be a big deal. My advice is when it comes to structural issues, I wouldn't stay too much on that with people because most of us are not structural engineers and we really need to think about what we say to people. And if we do think there's a major structural issue, we might suggest that they hire a structural engineer. But I do want you knowing that with severe wood decay, it's usually going to be greater than 20% moisture. So as you're going through crawl spaces, and we're going to even talk about moisture meters, the amount of moisture and percentage is going to be a big deal on telling you kind of what you're running across and what you can do about it. On this screen, you can see photos of brown rot. If you look especially at the photo on the left, you'll see that brown rot can crack perpendicular to the grain. So it actually cracks cross grain on the wood itself.
Fungi is a living organism that does not require sunlight to grow. Wood decay fungi generally grows in wood with a moisture content above 20%. Wood with a 30% moisture content is especially unacceptable. Using the eye tracker to detect moisture. When we see an area of interest where there might be some moisture issues, we put the moisture sensor on that area and we get to see what type of moisture is in that wood. The moisture sensor measures relative and direct humidity, so it gives you two ways to measure what's going on in that area, and we see this as a great value.
I wanted to quickly drop in this slide of a humidity map of the U.S. So as you can see in this slide, you're going to have definitely more humid areas in the southeast, all the way up through the northeast, the Great Lakes, and the upper Midwest. As you go out west into the desert, you're going to have states like Arizona, New Mexico, Nevada that have a very low relative humidity. So keep this in mind when you're thinking about your inspections, what the humidity is, and how this is going to affect the types of insects you would come across in your area, and including moisture issues in crawl spaces. Let's take a look at wood-to-ground contact. Wood-to-ground contact is another important issue to note in a crawl space inspection. Anytime wood touches the ground, it is absorbing moisture from the soil. Termites can easily attack this wood since they can build the tubes right up the sides while having a consistent food source along the way. So many of you have probably seen this where you got some wood to soil contact And many times, depending on where you're at in the country, you're going to see termites kind of working their way up the wood through the tube. So keep in mind, wood to ground contact is something that you're going to want to note on your inspection sheet, but it's also something that has to be taken care of. It's definitely going to do nothing good in the future, whether it's termites, whether it's wood rot. Everything is going to be able to attack that wood because its proximity to the ground touching there and moisture coming up it. One of the other things you need to note when you're doing your inspection is the condition of the vapor barrier. That's why we titled this slide, Is There an Adequate Vapor Barrier? Now, obviously, when you're doing your inspections, you're going to look for things like a bunching up of the barrier itself. Maybe it's been pulled back in areas. It can have leaves on it. It can have soil. It can have debris. I mean, there's just 50 different things that can be wrong with a vapor barrier. But you definitely need to note the condition on this because a good vapor barrier is imperative to keeping the moisture down and the condensation from rising up to the floor joist. As we've been mentioning, areas of the country can be more prone to this in the Gulf coastal states, the Northeast, the Midwest. But anywhere you're at in the country, make sure your vapor barrier is good. Make sure you note this on your graph and make sure it's something you look at when you're looking at remediating issues in the crawl space. Moving further along on our inspection, we need to look for things like debris in the crawl space. Debris in a crawl space is obviously another conducive condition. Debris often has cellulose material in it, such as wood. The debris must be marked as part of your inspection on the graph, just like everything else we've talked about. Debris always needs to be removed later. So as you can even see in this photo here, there's definitely things like wood and debris under crawl spaces usually. Any of that is going to be an absolute buffet for termites. So this is an extreme example here of wood in a crawl space, but I can tell you people have things like old boxes, stored items with paper in them. Those are going to be major things to take care of to get rid of or prevent termites in a crawl space. Plus, you need to be able to get around under there, and you also need to be able to lay a vapor barrier or at least check the barrier underneath debris to see if it's still good. So definitely part of your plan in the inspection is to write this stuff down and then make a plan later to remove debris in crawl space. I gotta tell you, there's so many things we can look at on inspections of crawl spaces that we could probably be here all day and not list them all. But I did want to mention that now that we've done all this work on the inspection and everything else, make sure you're documenting it well. So we mentioned before that each one of these steps you're finding wrong, you're going to need to document on a graph. For the sake of time in this course, we're not going to go over the whole graphing process. You just need conducive conditions that are noted. These are the things you're going to need later because you can't really build a good treatment plan without having good documentation of what you found. Then it's much easier to make solutions to solve the problems you have.
Let's discuss why crawl space isolation from the living space is important. When we talk about what is going on in the crawl space as it relates to potential pesticides and the use of treated wood, we understand further why isolating the crawl space from the living space is so important. That leads us to our next problem, which is the biological contaminants that can exist in crawl spaces. Just using that term sounds concerning in most people's minds. The reality is, most people want to be made aware of these types of issues and have a solution presented to them to correct the problem. This is going to further show the importance of why sharing the crawl space air with the living area air doesn't make sense. This takes us back to why we need to use a dehumidifier in a conditioned crawl space, because we don't want the living space and crawl space air to mix. Next, we will look at dehumidification, sized in accordance with manufacturer specifications. Using a dehumidifier is the only way to truly control the relative humidity in a crawl space to a set RH point. The dehumidifier can also help control the humidity in the living space by controlling it underneath of the home. The lower the RH is in the crawl space, the less of a chance any humid air enters the home through air mixing. Looking at this on a pros and cons level, the only con is the equipment and operation cost. There's always going to be an energy penalty for using dehumidification. This cost is nominal in my opinion, and pales in comparison to the issues you can have related to not conditioning a crawl space the correct way. At this point, we have established that the only true way to protect a conditioned crawl space is by adding a dehumidifier. The dehumidifier is the best option because you can set it to control RH and keep it below 60%. Microbial growth or mold will not form on wood materials. Odor from bacteria will be minimized. Again, if there's a musty odor in the living space of a structure, there is some sort of bacterial microbial growth. Comfort levels in the living space will actually be improved. Another benefit to this is if we control the RH in the crawl space, this should allow the homeowner to set their thermostat at a higher temperature because they will be more comfortable at a higher temperature with lower relative humidity. An example of this would be 95 degrees in Arizona versus 95 degrees in Florida with humidity. Finally, this helps protect the wood in the home as well. Looking at humidity removal, the dehumidifier is the only viable solution. The key word here is removal, not dilution. All the other forms of conditioning, a crawl space we talked about, are dilution. The focus in the building industry has been building a high efficiency and tight home. The reason why we have been talking about code is because it's helping achieve those goals. Another important point pertaining to energy efficiency is the fact that expecting our air conditioning systems to condition the crawl spaces of homes is counterproductive to whole push for energy-efficient homes. It's very possible that those other forms of conditioning a crawl space may go away as the code is updated. With humidity removal, the dehumidifier dries moisture by getting it out of the space. It really makes sense to get a high-efficiency dehumidifier with low-temperature operation because this is critical for crawl space. There's a big difference between a dehumidifier you can pick up at Home Depot and a commercial-grade crawl space dehumidifier. The commercial-grade dehumidifiers are designed for low-temperature operation. The point is, those dehumidifiers not designed for crawl spaces lose capacity quickly once they get below 65 degrees, which is the average temperature in a crawl space. I remember growing up in the Midwest with a cheap dehumidifier in our basement, and as soon as you turned the knob past 1, it turned into a block of ice. Finally, having a dehumidifier with high air filtration is important as well. Sizing dehumidifiers. Based on the 2021 code, as we mentioned earlier, the sizing is based on manufacturer's recommendation. There is no regulation on the manufacturer on how they set their parameters on this. You need to go into the crawl space and measure the RH, but that's just a snapshot in time. You can use data loggers to get a better understanding. That brings us to the size of the crawl space area. This should always be measured during your inspection. The temperature of the inside the crawl space is the other factor we need to consider. Remember, for every degree the temperature goes down, the RH goes up 2%. Also, for every degree the temperature increases, the RH goes down 2%. RH and temperature give you a dew point, and that really lets us know how much moisture is in the crawl space. Another important thing to note is the fact that it's easy to undersize dehumidifiers, and it's hard to oversize them. There's a lot of articles out there about how easy it is to oversize a dehumidifier. And that's just not the case. When you set a dehumidifier to a specific RH, it's only going to run until it gets there. There's no concern of drying out a crawl space too much. Now, if you have a dehumidifier that can't handle the moisture load in that space, it's going to run and run and run because it can't achieve that RH setting. This can make their utility bill go through the roof. This is why you always want more capacity than you need. The last thing you want is a homeowner calling you because you installed a dehumidifier that isn't doing what you said it would do. Dehumidifier air movement ducting. I highly recommend that dehumidifiers on the exhaust or the supply side be ducted with flex duct away from the dehumidifier. This will dramatically reduce the short cycling on the dehumidifier because we're not creating this microclimate where the RH sensor and dehumidifier is being affected by the dry air coming out of the eye back end of it. It also helps get drier air to the farthest corners, where we might hit dew point, especially in oddly shaped crawl spaces. These could be crawl spaces with a T or L shape. The ducting will help distribute dry air into those spaces and get better overall RH equilibrium in that space. This is what that would look like, using a commercial compact dehumidifier. As you can see, we're getting that drier air away from this area of the crawl space. This also allows us to be able to locate the dehumidifier in a more easily accessible area, closer to the crawl space door. We will need an electrical plug for the dehumidifier inside this area. Our goal is that the dehumidifier will be maintained better if we locate it in an area with easier access. As we talked about earlier, dehumidifiers are recommended to be located centrally in the crawl space, but that makes it harder to get to them and maintain them. By ducting them, we're able to locate them at a better access point and still get the better communication of drier air throughout the space. As we talked about before, the units that big box stores are selling are just not going to function as we need them to in a crawl space setting. I can also tell you, the Consumer Product Safety Commission has recalled 1.5 million of these portable dehumidifier units as of August 2023. This is due to a risk of fire or burns. This is just another reason to use a commercial crawl space dehumidifier. I'm going to say any customer would quickly agree with you with that knowledge being shared with them. The fire risk is related to control boards that have a risk of catching on fire. Most of these dehumidifiers control boards were manufactured in China and are not up to US standards. You can do a quick search for dehumidifier fire on YouTube and understand why we are saying this. Plus, that's something you can always show a potential client when presenting the need for the right type of dehumidifier. Looking at homeowner benefits of adding a dehumidifier, we can start by saying this leads to a healthier and happier home. This is achieved through better indoor air quality in basements and/or crawl spaces, which means better air quality in the living space. Again, 50% of the air in the living space is coming from these areas below. In any green grass climate where you get an inch or more of rain per week in the spring and summer, a dehumidifier is going to lead to better indoor air quality. The dehumidifier will also help with a reduction in adverse health effects and respiratory issues by controlling humidity levels. They help protect against moisture-related damage to the home and lead to greater comfort in the home. Due to reduced humidity, they help by leading to fewer pest problems and help you develop an ongoing relationship with the homeowner. This is because the dehumidifier needs to be maintained. The condensate line should be looked at least once per year, and the filters need to be changed out. It is highly advisable to set up a maintenance service program on the unit with the homeowner to check the unit on regular intervals. One question we often get is on the amount of electrical usage of the dehumidifier. Homeowners want to know how much their energy bills will go up. There's a website out there called RedCalc. It's by Residential Energy Dynamics, and they have a residential energy usage calculator. I put in the power rating, which is the watts of a compact dehumidifier made by Santa Fe, including the number of days in the year it was going to be in use, and estimating that it will be running 20 minutes out of every hour during each day. These estimates are very aggressive because I wanted to show the worst case scenario on usage. I also put in 13 cents per kilowatt hour because this is a reasonable estimate based on electrical costs. You can always go a step further and get a copy of the homeowner's electric bill and see what their rates are, but a lot of times that involves peak and non-peak times. Electric companies are known to charge differently for peak and non-peak hours, and estimating like we did here is the best option, in my opinion. You'll notice it's only going to cost $126.70 annually to run this compact chimerical dehumidifier. This proves just how energy efficient these types of units are. In the next portion of our course, we are going to use materials provided by Santa Fe dehumidifiers on encapsulating a crawl space. On this slide, you are seeing a list of recommended supplies. Our first supply would be a 12 mil CrawlGuard reinforced liner. Our second supply is a CrawlGuard sump pump kit. Our third supply is a 7 mil white sealing tape. Our fourth item needed is a CrawlGuard black double-sided foundation tape. The fifth item needed is CrawlGuard foundation pins. The sixth item needed is professional grade caulk. The seventh item needed is a CrawlGuard felt underlay. The eighth item needed is Santa Fe crawl space alert, optional. The ninth item needed is a Santa Fe condensate pump kit, optional. The 10th and final item needed is a Santa Fe dehumidifier. One thing you want to note is, this isn't a comprehensive list. The reality is, encapsulating a crawl space can be a complex job. This is a minimum list to help you get started. Removing any batted insulation currently installed in the crawl space. It's an excellent idea to wear a Tyvek type of crawl suit when doing this. This fiberglass type of insulation is very uncomfortable to work with. After doing these jobs, you can feel very itchy and may feel as though someone has cut your skin lightly and repeatedly with a knife. I use that description because it's the best way to describe how uncomfortable it can be to have any of your skin exposed to the insulation when completing this part of the job. As you're pulling the insulation from the bottom of the subfloor, use a tarp to stack the insulation on and pull it in batches. This is much easier than dragging it piece by piece out of the crawl space and to the haul-away point. Reinstalling insulation. It's important to note that customers will typically want new insulation reinstalled. This makes sense because a crawl space encapsulation will not keep the space conditioned at the desired level without this step. In my experience, the best way to re-insulate a crawl space is with foam board insulation. Measuring the foundation walls. In this step, we are going to measure the foundation walls vertically and horizontally. This will give us the required dimensions for the foam board insulation. Once you have your measurements, using a set of sawhorses outside of the crawl space is the best way to support the foam board while cutting it. A T-square is a great tool to keep you in line when marking your measurements. And next, we can use our circular saw to make the cuts we just marked in the last step. We can now bring our cut pieces of foam board into the crawl space. It is very important to make sure you lay them out correctly in the crawl space. What I mean by saying this is, the crawl space walls are typically varying heights, and you must make sure to code the foam boards correctly in correlation to where they will be placed. I use a method of writing on the block walls a number, and then writing a number on the corresponding foam board piece in magic marker. I always write the number on the side of the foam board that will not be visible when installed. This is because you may not always be encapsulating over your foam board insulation and don't want the writing to show for aesthetic purposes. As we start adding foam board insulation in the crawl space, we need to cover over the foundation vents as shown. This is accomplished by inserting them into the vent openings and foaming around them, adding foam board to the crawl space walls. Leaving a gap for termite inspections. It's important to leave a 4-inch gap at the top of the crawl space wall for future termite inspections. We're now going to need 4 tools to attach the foam board insulation to the crawl space walls. First, we'll need a .22 caliber concrete nail gun. And next, we'll need a box of concrete nails with built-in washers, as you can see shown here. Make sure you have the correct length on the nails for the thickness of the foam board insulation. Finally, we need .22 caliber nail gun bullets. Make sure you purchase bullets compatible with the model of your nail gun. Our final step in this process involves loading the nail gun with a bullet and nail, then pressing it against the foam board with it pressed tightly to the wall. I highly suggest wearing ear protection during this process. You need to keep in mind that you are going to get a loud bang, similar to firing a .22 caliber rifle, and nothing in your career is more important than keeping yourself safe. At this point, just pull the trigger and the concrete nail shoots through the foam board and sinks into the block wall. That's it. We have installed our first sheet of foam board insulation. All we have to do now is repeat the process until all exterior walls are insulated. At this point, we have finished our process of re-insulating the crawl space. Add the sump pump. Our next step is adding a sump pump for bulk water management. This is a crucial step. If you close a crawl space and fail to deal with bulk water management, the conditioned crawl space will not function properly. The drain system will be installed around the perimeter of the crawl space. The system will go beside the footer and is installed in the lowest side of the crawl space. The simple rule to remember is that water flows downhill. Putting the sump pump at the lowest side of the crawl space gives you the best opportunity of any water intrusion to be funneled to the sump pump. Once the sump pump is dug out, you need to add gravel to the surrounding area of the hole. This requires you to make sure the hole has about 18 inches of extra width on each side of the sump pump. You can then add the gravel that allows the area to drain correctly. Next, we will use a concrete core drill and bit to drill through the foundation wall. Make sure the drill bit is the correct width for the drainage pipe to fit through the newly drilled hole. Use caution to make sure you don't drill into any foundation areas with existing pipes. Looking on the outside of the wall should confirm if utilities are present in the area. We are now ready to finish hooking up the sump pump by finishing the plumbing drain pipe and dropping the submersible pump into the basin. One last note on this is you need a plug-in available to power the pump. I have found the best way to do this is to hire a licensed electrician to make sure you limit your liability, and it's all up to code. Before we put down our vapor barrier, we need to lay down a felt liner on the floor of the crawl space. This adds another layer of protection to help keep the vapor barrier from being punctured. You have to keep in mind that service people will have to enter the crawl space from time to time, and the barrier needs to hold up for the long run. Our next step involves using double-sided tape. This involves adhering the tape about 4 inches below the top of the block foundation walls and the piers throughout the crawl space. At this point, we're going to cut our pre-measured sections of vapor barrier to take down into the crawl space. Make sure to cut these outside because space is usually limited underneath of the home. Once we have our sections of vapor barrier underneath, we attach them to the double-sided tape. You can see here that we have several inches of extra barrier extending out into the crawl space, jot floor. This is so we can overlap the floor barrier up on the walls. This makes seaming the two together much easier. You would never want to try tape 2 sections together with them barely meeting. You need an overlap of 12 to 18 inches. We then add our foundation pins into the tape line area as shown here. This helps to support the vapor barrier in the future. We finish the walls off by adding a line of our seaming tape over top. Then, we lay the vapor barrier down on the floor and seam it up as you can see here, using the seaming tape. This same process will be completed around the piers. If you cut the vapor barrier as shown here, it will be easier to seam these areas by wrapping the vapor barrier around the piers. The final step will be installing the dehumidifier as shown here. You can see we are supporting it with bricks. This can be helpful in leveling it and making sure it doesn't depress down into the soil over time. This is a before and after of the crawl space. This image really shows how clean the space should look when finished. You can especially tell that we started in the back corner of the crawl space and did not crawl and track dirt onto the new vapor barrier sections as we worked, I would use the analogy of not painting yourself into a corner and having to walk back over the painted area to get out.
Congratulations, you have completed the course. Please proceed to the 20-question quiz. Please drop us a line and give us your comments on the course, pestceus@gmail.com.